Welcome back. It's time for our fifth and final video from Unit 3. We'll continue our discussions on methods and strategies for subtracting whole numbers. So let me fire up this PowerPoint and share it with you, and we'll get into it. All right, we're on the current slide. Okay, when we considered addition, we looked at closure, we looked at commutative, we looked at associative. So we'll spend a little time and we'll try to figure out if we change our focus, if instead of adding, we say, let's subtract, which of these properties do we believe will still hold as it relates to subtracting for whole numbers? So the question is, do you think the whole numbers are closed with respect to subtraction? And you say, well, geez, I don't know. But you know what? If you think a little bit, I think the answer is going to come up to be no. And you say, well, talk to me. Well, look, if you grab the numbers like 3 minus 7, right? 3 and 7 are certainly whole numbers, and you can grab those and you can subtract them. But the answer to 3 minus 7 is sure as shooting not a whole number. In fact, it's a negative. So sadly, with respect to subtraction, the whole numbers are not closed. So we'd have to say no on closure. Commutative, and you say, well, does order matter when we subtract? Well, I kind of think it might. I kind of think 7 minus 3 might be different than 3 minus 7. So it looks like we're going to go 0 for 2 here. And the idea that when you're subtracting, order seems to be significant, unlike when you add, where order doesn't matter at all. So addition is commutative, but subtraction is not. Associative, you're probably kind of catching on here. Things are coming up a bunch of no's, and you're going to get the same idea here. If you do 10 minus 7, then from that subtract the 3, you will in fact get a different answer than if you did the 7 minus 3 first and subtracted that result from 10. So far we're pitching a shutout. Nobody came up yes. So when the operation involved a subtraction, it's not closed, it's not commutative, it's not associative. You say, well, I'll bet you there's an identity element. I bet you it's still 0. And it's cute in that, you want to say yes, but the kicker is if 0 is your identity element, 0 has to be able to play both places. 7 minus 0 has to generate the same answer as 0 minus 7. And sadly, that's not going to be the case. So we don't even have an identity element with respect to subtraction. So the properties are we're kind of like, dang, not getting so good stuff. When you were a little kid, the idea of solving equations was introduced with symbols. Some of you might remember like a big old rectangle box or a question mark or something like that. So it's a most primitive form of an equation, and you should say, well, shoot, I know the little triangle would have to be worth 3. And I'm pointing this out because I want you to realize that while you and I look at equations as a very algebraic concept, and we trace that success or frustration to pre-algebra and algebra, the notions of solving an open statement like that, really for little kids, go back to second grade, maybe even first grade. Okay. Base 10 blocks to model subtraction. The notion of takeaway is a very significant thing. And again, it enforces the idea of borrowing. So we're going to look at the model for 243, takeaway 61. So on the desk, and again, if we had a desk and I was standing in front of you, we wouldn't do this by PowerPoint. We would actually model it. You have 243, that's 2 flats, all right? That's 4 sticks, and that's 3 singles. And from that, you are being challenged to take away 61. Well, it's easy to take away the 1. You have 3 singles, so you can certainly take away one of those. The problem we're going to encounter is you're going to be then asked to take away 6 sticks from a collection of 4. So we're not going to have enough. So we're going to wind up having to trade the flat. All right, so we're going to borrow. That's the phrase you guys have grown up with. So here's the arithmetic. All right, we can take away the 1 on the singles. That's easy. But if we swap out one of those flats, and we get some more sticks, then we'll have enough that you can take away 6 of the sticks. And I believe that's what you're going to see next. There's the 6 that we're taking away. And you say, well, shoot, I still have a bunch of those sticks left. Yeah, it looks like I might have 8 of them. And you see we've also taken away the 1 single out there. So we have 2 singles. It looks like we have 8 sticks. And it looks like we still have that 1 flat. Remember, we traded one of our 2 flats to get enough sticks so that we could take away the 6 sticks. So there's what's left, 1 flat, 8 sticks, and 2 singles. So again, I want us to do this with kids. I want them to get the idea of what does it mean to borrow. It's a very cryptic concept, and you're going to find that when you work with math with young students, the notions of carrying and borrowing are the places where frustrations probably occur. So the kicker for kids here is if you give them a chance to do it by modeling with the base 10 blocks, it's going to be a good thing. I like this one. I like equal add-ins. I think the kids are going to think the numbers fall from the sky. So I'm going to show it to you. You're going to say, wow, that's cool. All right, you ready? What I want you to realize is it's a pain in the neck to take 161 from 352. When we're subtracting, it's really nice to subtract if that bottom number has lots of zeros. So we're going to somehow create a different number where you and I see the 161. We're going to create a number that has a lot of zeros. So what are you going to do now? Well, I'm going to change the 1. I'm going to add a 9. And again, people are like, well, the numbers are just dropping out of the sky. Well, if we're going to add 9 to that guy, I'm going to have to convince you that I'm going to add 9 to the other guy as well. So now my arithmetic problem has changed. So now it's that. Now it's 361 take away 170. And that's not a whole lot nicer than the first one, but if I could say, shoot, if I'm going to add stuff, why don't we keep on going? Let's add 30. Let's turn that 170 into a 200. You kind of already know that I'm going to have to add 30 to the top guy. Now I want you to look at this problem because that's easy. That doesn't involve any borrowing. That doesn't involve any pain and agony. That's an easy subtraction problem. So what we did is we took a problem that really wasn't that easy to look at, and we created one that I think most kids are going to say, well, I can solve that. Shoot, the answer is 191. I like it. I like it. We could have done it with one addition. We could have just added 39 instead of adding the 9 and then the 30. I think it's worth showing kids. I don't know that I would require it on a test, but I think it's kind of cool. All right, switching focus. These are mental strategies for computation. All right, we've done breaking and bridging before, so you kind of already know what's going to happen. You're going to take away the 30, then you're going to take away the 8. So 56 take away 30 is easy, and we still have to take away the 8 from the 26, and that gets us down to 18. So we broke the 38 apart and took away the nice part, the 30 part, and then we took away the 8 that we still had to take away. All right, trading off. It's easy to take away certain things. What are you going to do, Dal? Well, I'm going to, shoot. You know what? This is kind of like what we just saw there where we changed the numbers. So we're going to add 1 to the 36, and that's pretty cool if you'll let me add 1 to the 29. And now I'm going to just get an answer of 7. So we traded out some numbers and made the arithmetic easier. Dropping out the zeros. I wish more kids were aware of this. All right, so you really are just looking at 38 take away 25, and then the zeros reappear. All right, so 13 as a result of that subtraction, then bring the zero players back. All right. Okay, believe it or not, I have actually seen the Imagination Movers live. I realize again I'm aging myself here. Okay, so I went shopping, found an Imagination Movers DVD, a respectable $11. I cashed out with a 50. And the cashier says 11, 12, 13, 14, 15, 20, 30, 50. The question says, how many bills did Firster receive in change, and what denominations were there? So again, you see, the 11 is the price point. So the 12 and the 13 and the 14 and the 15 are probably $1 bills to get your total. You're counting up from 11. All right, so it looks like we probably got 4 singles. To get from 15 to 20 is probably a 5. To get from 20 to 30 is probably a 10. And to get from 30 to 50 is probably a 20. So I'm going to say, what did he get? He got 7 bills total. The denominations, 4 of them were singles. 1 was a 5. 1 was a 10. And 1 was a 20. My friends, that gets us to the assignment for 3B, and it wraps our work for Unit 3. So grab your trusty book, grab your trusty pencil, some paper to work out. You'll find there is an assignment 3C. It's just a collection of problems that you can work on. So again, send me some work at the Dropbox for 3B. Go ahead and finish 3C. There is an assessment for Unit 3. It's not particularly long and violent, but that wraps our work on Unit 3. I'll be back soon for a look at Unit 4. See you then.